Section 8.6, we're now going to look at law of sines and law of cosines. So this entire time when we've been dealing with trigonometry, we've been dealing with right triangles. The law of sines and the law of cosines are used in non-right triangles. So we're going to start with the law of sines. I believe that that is the easier of the two. And then we'll look at the law of cosines at the end of this section. So what is the law of sines? Well, the law of sines looks like this. If I have a triangle, a non-right triangle, we're going to say that the law of sines is sine of A over A equals sine of B over B, which equals sine of C over C. So really what we're saying is we want an angle pair relationship. So if I'm dealing with an angle measure A, I want the side length that's across from it. That should be equal to sine of B over the side length of B, and then really equal to sine of the angle measure C over the side length C. So notice how we're dealing with an angle side relationship that's across from each other. So we're going to treat this kind of like a proportion, really, when we deal with this. So an example as this, what this looks like, it wants us to find x and round to the nearest 10. So I want to come up with angles and sides across from each other. And I always like to start with the variables. So if I see my side length x, the angle across from it is 21. So we would say sine of 21 over x is equal to, now I'm looking for another angle side relationship. I see another angle of 97 and across from it is 16. So we would say that it is equal to sine of 97 over 16. And from here, we can cross multiply. So this direction, we would get x sine of 97 equal to 16 sine of 21. To get x by itself, we're going to divide by sine of 97. So now we have x equals 16 sine of 21 over sine of 97, which we can plug into our calculator. So 16 sine of 21 divided by sine of 97 gets us 5.8 as our side length. So we'd say x equals 5.8. I've got one more down here at the bottom that I want to show you, and it is 1b out of this one. So again, we're trying to use the law of sines. We're using, trying to find that angle side relationship. So I'm first going to start with my side length x, but notice how on this one, I don't know the angle across, r. We can find that. We know that in a right triangle, all angles in a triangle add up to 180 degrees. So if we take 180 minus 37 minus 54, that gets us 89 for our angle measure. So now we have sine of 89 over x equal to, my other side length that I know is 8, the angle across from it is 54. So we would say sine of 54 over 8. I'd have to do a little bit more work to find your angle side relationship, but stuff that we already know by just subtracting our angles from 180 degrees. Again, from here we cross multiply, so we have x sine of 54 equal to 8 sine of 89 divided by sine of 54. We got 8 sine of 89 over sine of 54. We'll take our calculator out again. 8 sine of 89 divided by sine of 54. And it gets us approximately 9.9 as our side length. We would say x equals 9.9. And that's how you would use the law of sines to find a missing side length.